Hello, folks. One more time. Today we're going to talk about vector. Vector is a high-performance observability pipeline. It enables a dramatic cost reduction, novel data enrichment, and data security where you need it. Open source and up to 10 times faster than every alternative. It is built in the Rust, so it is memory efficient. It supports logs and metrics, but the vector transforms logs and metrics into its internal events. So it processes events, and it supports end-to-end acknowledgements, not for all services, though. It is run by vector remap language. This is the very specific one, and you have to spend some time to just adapt yourself to it. Also, you can attach service accounts if we are talking about Kubernetes deployment. Also, it supports in-memory buffer by default, but you could also configure on-disk buffer. Yeah. Talking about vector, it could be launched in two states, let's say, as agent, like Diman said, and as an aggregator. Agent, just the main purpose of agent is collecting data from our Kubernetes cluster, and that's it. That is the whole purpose of agent. Let's move on. Yeah, about deployment, we can configure the observability of our vector agent. We can deploy it as a daemon fed one per node, or configure more specific configuration to make it a sidecar for some specific pod looking into some specific file, for example, a bunch of files on our main pod. Let's move on. Yeah, another role for the vector is aggregator. It retrieves data from other vector agents or, I don't know, multiple sources. It shouldn't be exactly the vector agents. Then transforms it via vector remap language and finds out the data to the sinks. The list of some list of available sinks is attached further in this presentation. Yeah, the collect, transform, and route model, as we can see, according to the picture, the initial data is specified as sources. It supports maybe 40 something sources, different sources, but we can see files, syslog, stats there, also Kubernetes logs, and so on. When it comes to vector, it then process each log or metric is processed as event, and then we can manipulate those data via transform, route, separate flow on some condition, for example, I don't know, based on the Kubernetes label or something that we can design. After transforms, we can sync it to a bunch of services, and for mention like S3, Elasticsearch, Prometheus, and there are a bunch of them. Okay, let's move on. Here are a list. Here's a list of sources, transforms, and things. It is maybe not popular services are listed here, but at least the most popular ones. I can, yeah, let's move on. Talking about the topologies that we can implement using vector is distributed. We can start from distributed. This is the simplest topology. In a distributed setup, vector communicates directly with the stream services from the client node. Talking about pros and cons. As for pros, it is simple and elastic. We can just configure it in a different way. And as for cons, it is less efficient. I can say it's less durable, more downstream stress, and lack multi-host context. Let's discuss further topologies. Yeah. Now we can see observe the centralized topology. This is a good balance of simplicity, stability, and control. For many use cases, the centralized deployment topology is a good compromise between the distributed and stream-based topologies, as it offers many of the advantages of the stream-based topologies, such as clean separation of responsibility without the management overhead incurred by a stream-based setup. Talking about pros, it's more efficient, more reliable, has a multi-host context, but it is more complex from another side. And the last topology is stream-based. It's the most durable and elastic topology. This topology is typically adopted for very large streams with teams that are familiar with running stream-based services, such as Apache Kafka. As for pros, we can say it's more durable and reliable, most efficient, ability to restream the data and cache them after some time, cleaner separation of responsibilities. As for cons, it increased management overhead, more complex and more expensive, of course. Let's move on. Yeah, the good point to mention is the supported operation systems and sources where we can run it. I mentioned Kubernetes. Yeah, we can put in Docker and just install it as a service or a package for our Linux, Raspberry Pi, Windows, Mac. It is useful during the debugging. When you're trying to put some code and configuration into the Kubernetes, you can easily install it on your machine and debug the same code with a snippet of the log, and do not overwhelm yourself with Docker desktop and so on. Available packages are here. You shouldn't necessarily run it in the Kubernetes. You can run it as a service, or there are on the official website. There are a bunch of examples and use cases where you can use it. So basically, you just install it as a usual package and then manipulate it as you wish. Vector map language is an expression-oriented language that designed for transforming the observability data. And as I mentioned, it's really kind of unique, has unique syntax. So you have to just read through the documentation. And as per my experience, it is not very well documented because there is no strict separation between tabs and operators, some functions, and so on. So you have to spend some time to navigating some concepts of it on the Vector website. But it's okay, it's adaptable. Here's some text that we just example from the official website and how it parses the message. I can, from the second snippet, I can just annotate the exclamation mark. It stands for abort, represents a optional. It can be optionally used for failable function to abort the program when the function fails. If the parse JSON, for example, is not working as expected, it throws an error. But this message could be handled by specifying the error message. We're specifying the body and the error message, and then that error could be handled separately. But it's readable, and that's it. As I could say, that's just a simple example. Why we choose Vector in our scheme, and our task was to store Kubernetes logs, all Kubernetes logs to S3, and afterward grab some data from S3 to back to aggregator and put them in Elasticsearch. And the process of pulling data from S3 works only from with conjunction with SQS. That's how I understand it. There was an only option. And of course, we should configure the S3 event notification, and that would be going to SQS and would be processed by aggregator afterwards. Yeah, I can move on to the next slide. Here's our code structure. I've rule out the Elasticsearch configuration. It is simple declaration. Here we can see the module. Of course, we are implementing our project in Terragrant, but Terraform module is present. Here we're declaring S3 and SQS like for our setup. And vector agent, the vector aggregator contains some basic configuration for the Helm chart. We can set up both role through one Helm chart by specifying different roles. And here we have some basic pre-configured templates that would certainly define each separate role for which purpose it runs. And the vector aggregator contains IAM roles, secrets pulled from the AWS Sequence Manager, and Helm release resource in Terraform. In our Terragrant folder, we have just default Terragrant file and some more specific values for each Helm file, aggregator and agent. Here is the basically the configuration of Terragrant. Nothing special. Just at the bottom of the screen, we can see that we are passing the agent and aggregator YAML files with all of our details and the parsing logic. Aggregator YAML is more complex because it contains lots of roads and rules to basically roads and rules to parse our logs and our data. Agent is just simple setup, what to pull and where to sync. Just it. Yeah, we can move on. As for alternatives, you probably know better than me that the tools like Prometheus, Logstash, and Telegraph. From that info that I've googled, it seems like these tools can implement the same configuration with storing data and parsing it. But I don't know, as an alternative, Vector is also good. Also, I should mention the Vector has a lot of pre-built function that could parse strings, some Nginx, Apache logs, most common JSON, and so on and so forth. So you shouldn't overwhelm you with just digging into parsing logic and regular expression. That is just easily doable with some default functions. And that's pretty much it, I think. Yeah, that is the last slide. So I'm open to discussion, questions, suggestions, feedback.
We have the first question. When it comes to selecting the tool before the project starts, could you give like kind of advice or approach when and how and why should we select, for example, these of which you mentioned, like Fluentd, Logstash, and other tools? I mean, very often when we discuss the concept of the architecture with the customer, we need to give them advice. So what parameters should be considered when choosing this tool? This is the first part of the question. And the second part, like as far as I understand, it's Vector is relatively new tool. So is it ready for production use? And for example, how does it work with a big amount of log data? Because the tools we mentioned, Fluentd, Logstash, they are proven for years in different large scale deployments. And Vector, actually, the first time I heard about it is the presentation. So wondering how it could work in production environments.
Yeah, thanks for the question. I read about as agent is more stable. I think the aggregator that what I read from the official website. I could rely on the speed, maybe, but it is not critical in logging, to be honest. But the tool, what I suggest. I'm not an expert with all of these techniques and different sources. That is another part of the investigation process, I would guess. It's up to the customer. Maybe we can suggest an alternative solution. If customer is easy to it, we can adjust it. If it's more conservative, we can stick to to other solutions. But I couldn't provide you with much detailed information. That is, I think, presentation for another topic for the presentation, the analysis and differences between all that techniques. Yeah.
Like
Probably I can add something to Maxim's answer. Probably the most important thing of the vector is that it is able to store logs somewhere on third-party service, for example, S3, etc. So we, for example, in our setup in Iris, we have a problem when our log stash is overwhelmed and Elastic stops receiving some data for some reason, and we lost some logs with. If we would implement the vector, probably these logs will be stored on S3, and in case of something happen with Elasticsearch or Logstash or whatever, these logs are anyway stored on S3. We can parse it later and put back to Elastic without losing them. So it's probably the main one of the features that vector offers us.
Yeah. Also, we should mention the integration with SQS that also adds additional, say, processing ability, and just not to overwhelm yourself with a bunch of logs to process. We just process each log at a time, and depending also SQS has some parameters to configure, and we can adopt our stream load via SQS also, counting our performance or machine performance.
point of view, I'm sure if you worked with any other tools to compare, but maybe somebody from our guys, is it easier to work with Logstash for us as engineers, or it doesn't matter actually? We can use any of the tools available. I mean, at work, so for us, would it be better to use Vector or any other tools also okay?
The specific vector specifically was selected for this project just because Logstash doesn't support using role for communication with OpenSearch in AWS. So to have Logstash configured to expose logs and process logs to the Elasticsearch, you have to provide AWS key and secret into the configuration. So you need to manage storing it somehow in your source code or provide in a different ways during deployment. It was one thing to choose vector, and another one we can have vector against reads the logs from specific environment, from specific node, and it very fast to read this data without processing and put somewhere. Because S3 is scaling automatically for us. We can send a lot of files to the S3 without worrying about the throughput limits we have. So we can be sure that all our logs will be stored properly on S3 bucket. And then Vector or Logstash or any other tool which can take logs from S3 can process them, remap them, and put to the Elasticsearch. Having both vector and something else for processing doesn't make sense. So instead of using and learning different tools for process logs, we can use only vector for this. And because it also provides us a chance to collect metrics, not only logs, we can use it instead of node exporter or some other tools that we are using to feed the Prometheus with metrics.
are available that we have experience and expertise with this tool, I can and I will use it in my sales speeches. Thank you. Maxim, do not hesitate to ask. Go ahead. Finish with my question. If I would have any, I will ask.
Yeah. Any other question, guys?
One just get it and hopefully we will use it somewhere.
Any
We're
questions?
already using it on one project in not fully production, but almost in production environment. And I believe the next project where we are going to implement it will be Iris, because we have a problem there mentioned by Sergey, and Vector will definitely help us with solving them.
Yeah, question from
Please that
Andrei.
people.
Yeah, which is open source, completely open source and free as a result.
It's not well documented. Is it right? I mean, how easy is it to get used to it if you are new to this technology?
I would say some parts are documented as it should be, but as for the vector map language, also, although it is has some pre-built functions from the box, it is difficult to get into some expressions and operators, as I've explained, the exclamation mark or something double question mark, so that responsive for the logic. And sometimes you have to debug locally in order to understand how it works, because sometimes it is not processing the actual message and doesn't throw any error, and you are just doing something but not receiving something that you expect, and that's why there is the most hesitation comes from. But as I mentioned, it is just easy to troubleshoot it on the local system.
As I wanted to say, the minimum value of these sessions are that everyone knows that we already use this technology, that this technology exists, and there is a person in our team you can go and ask you if you have any questions. So great. Thank you very much, Maxim.
Yeah, thank you guys for attending.